Hello everyone, welcome to the section A of the internal free assessment review. In this comprehensive section, we are going to tackle the first 20 multiple choice questions, which serves as the foundation bedrock of our data science curriculum. We will be traversing a wide landscape of topics, starting with difference between hypothesis-driven and data-driven research paradigms, and moving all the way to the specific storage mechanics of unstructured data. Along the way, we'll break down essential statistics rules like 68, 95 to 99.7 rule for nominal distribution and explore the core mathematical concepts that power our algorithms, such as minimizing the residual sum of squares in regression. We'll also touch upon practical implementations, details including SQL joins, Python's double-ended query, and big data storage in head-ons. There is a lot of ground to cover here. So let's dive in and ensure that we master these fundamentals, each one step by step. Hello and welcome everyone to the video series of the third internal assessment of the data science assignment. So in this video, we will be tackling the section 1 of our internal assessment third. So here we'll answer the each question along with their detailed explanations of the following questions. So question number 1, which paradigm of data research involves asking what problems can be solved given some data? Options are hypothesis driven, data driven, model driven, and analysis driven. So its correct option is option B, which is data driven. So in the data-driven approach, we will begin with an existing data and explore what insights or problem emerges from it. So patterns guide the research instead of predefined assumptions made by them. This method is common in machine learning and exploratory analysis, where data reveals opportunities or in the unknown beforehand. Question number 2. Unstructured data cannot be easily stored in tables, spreadsheets, relational databases, or images or audio. Correct option is option A, tables. So tables require fixed rows and columns, but unstructured data like text or audio does not follow such structure. So because of this, relational table formats struggle to organize unstructured content meaningfully. Such data is better stored in NoSQL or in a file-based system. Question number 3. The probability of an event E is calculated as product of all probabilities, sum of all probable outcomes in E, average of probabilities, or maximum probability. Correct option is option B, sum of all probabilities of outcome in E. So the probability of an event is the total number of possibilities of outcomes belonging to that event. This basic rule ensures every valid way the event can occur contributes to the final probability. It forms the foundation of probability theory. Question 4. In descriptive statistics, which measure is useful for skewed distribution of data with outliers? A. Arithmetic mean, B. Geometric mean, C. Median, or D. Mode. Correct option is option C. Median. The median is a robust and unaffected by high or low values, which are our outliers. It represents the central point of the distribution, even the data is heavily skewed. This makes it more reliable measures for non-symmetric datasets. Question 5. During data cleaning, artifacts are irrecoverable information lost during acquisition, systematic problems that can be corrected, missing values, outliers from data collection. So correct option is option B, systematic problems that can be corrected. So artifacts are consistent errors. They are introduced during the collection or the data cleaning processes. Because they follow a pattern, they can be detected and fixed, and removing the artifacts keep the datasets accurate and unbiased results are followed by it. Question 6. Feature engineering is discrete data, includes scaling, binning, one-hot encoding, or block transform. So its correct option is Option C, one hot encoding. So one hot encoding converts categories into binary columns for model compatibility. And it also prevents the false numeric orderings and treat each category equally, thus avoiding any biasness. So this is essential for algorithms that require numerical inputs. Question 7. Normal distribution follows the 80-20 rule, 68 to 95 to 99.7 rule, Poisson variance equal to mean, or the long tails. So correct option is option B, 68, 95, 99.7 rule. So this rule shows how data is spread around the mean in a bell curve. Most value falls within 1, 2, or 3 standard deviation. It is widely used to for confidence intervals and detecting outliers. Question A. 8. In modeling, the term error E consists of only reducible errors, only irreducible errors, reducible and irreducible errors, and bias only. So correct option is option C, reducible and irreducible errors. Total errors included parts we can only reduce by improving the model and parts we cannot remove due to randomness. So understanding this helps set realistic expectations from our model. No model can eliminate irreducible errors completely. There might be some errors which may be left by it. Question 9. Occam research suggestions choosing the most complex model, simple model with equal performance, most flexible model, model with highest variance. Correct option is option B, simplest model with equal performance. So when two models perform equally well, the simpler one is usually more reliable. Complex model may overfit by capturing noise. That's why they are mostly unpreferred over the simple model. Simply and the simplicity improves generalization and interpretability. Question 10. Parametric models risk no assumptions about F, wrong assumptions leading to bad results, overfitting always, or high interpretability. So correct option is option B, wrong assumptions leading to bad results. Parametric models assume a fixed functional form. So if the assumption is incorrect, the model cannot capture the real relationship. So this results in high bias and incorrect predictions. 11. For classification evaluation, precision is TP upon TP plus Fn, TP upon TP plus Fn, 2 positive over 2p, or area under ROC. So we have, I guess, option incorrect C. We'll fix it later. So correct option is option A, sorry, option B, which is TP upon TP plus FP, which says true positive upon true positive plus false positive errors. So precision tells how many predicted positives were actually correct. It is useful when false positives are costly. So high precision means fewer incorrect positive predictions. Question 12. In linear regression, coefficients are found using second order optimization, minimizing RSS, maximizing variance, or clustering. So correct option is option B, minimizing RSS. So linear regression chooses parameters that minimize the residual sum of squares, which is root mean square. This ensures predictions that are close as possible to the real values. RSS minimization is the mathematical foundation of the model. Question 13. Logistic regression predicts numerical values, probabilities using sigmoid, clusters, or distances. So its correct option is option B, probabilities using sigmoid. So logistic regression outputs probabilities between 0 and 1. These probabilities are mapped to clauses using a threshold, and it is widely used for binary classification tasks. Question 40. Euclidean distance is Minkowski with k is equals to 1, 2, infinity, or 0. Correct option is option B, 2. Setting k is equals to 2 in Minkowski's formula give the Euclidean distance. This is which is straight line distance between any 2 points. It is one of the most commonly used distance matrices in machine learning. Question 15. K-mean clustering assigns observations to farthest centroids, closest centroids, random centroid, or hierarchical levels. Correct option is option B, closest centroid. So K means group point based on the minimum distance to the nearest centroid. And this is done to ensure that clusters have the compact shapes. And after each assignment updates, it trivially under until the model becomes stable. Question 16. Decision tree are prone to underfitting, overfitting, high bias, or low variance. Correct option is option B, overfitting. So decision tree can become too detailed, and sometimes it can also capture noise of the data, and this reduces generalization to the new samples, which means model may perform very good on the trained data, but may not capture the outputs or the real essence when it encounters any new sample data. So regularization or the pruning helps prevent overfitting. 17. In neural networks, activation function introduce linearity, non-linearity, bias only, or weights only. Correct option is option B, non-linearity. So non-linear activations allow neural networks to learn complex patterns, and without them, a network behaves like simple linear regression. So they enable weak models to approximate intricate functions. Question 18. HADOPS HDFS provides job scheduling, high throughput data access, SQL queries, or stream processing. Correct option is option B, high throughput data access. HDFS is optimized for large scale distribution storage, as it allows fast reading and writing of the massive data sets. And this all qualities make Hadoop ideal for big data workloads. 19. In SQL, to combine rows from two tables based on related columns, we use select, where, join, or group by. Correct option is option C, join. So what basically a join does, a join merges rows from different tables using a matching key. It allows relational database to combine information meaningfully, and joins are essential for multiple table queries, which means when we have to perform various operations on the multiple tables simultaneously. Now coming upon the final question of our section 1, Python DQ supports key value pairs, append and pop from both hands, unique elements only, and heap operations. So correct option is option B, append and pop from both hands. So what DQ stands for? DQ stands for doubly ended queue. So it allows efficient insertion and removal from both front and back of the queue. So this makes it ideal for implementing queues, stacks, and the sliding window algorithms, which we have studied earlier. So here we have finished up the section 1 of internal assessment 3. In the next upcoming videos, we will be covering section 2, 3, 4, and section 5. Till then, keep learning. And that brings us to the end of section A. We have successfully navigated through a diverse mix of theoretical statistics, me- machine learning algorithms, and practice programming concepts. From understanding why we use the median for slowed distribution to recognizing the artifacts are systematic errors we can actually fix. These questions test not just our memory, but the understanding of why behind the methods. We also clarified crucial distinction of in modeling, such as why decision tree are prone to overfitting and why the activation functions are the secret sauce that gives neural networks their nonlinear power. So make sure to review the definition of precision versus accuracy and the specific use case of tools like HDFCs and Python's DQ. Solidifying these basics is key for handling the more complex questions coming up next. Great job, and I'll see you soon in section B.